was given. Okay, so in order to know VO average, we know that VO average is equal to 2 V peak over pi, and V peak is the voltage across the secondary terminal of the transistor or secondary winding of the transformer, sorry, and therefore we can find Vp by saying it is V supply max, so V peak equal V supply max times 1/3, which is the ratio لأنه هي 3:1 over 3, okay, and this would be equal to 23.2 times √2 over 3. So we can find Vp max from the given RMS value at the supply side of the transformer. And then we can find VO average as 2 times V peak over pi. Okay, so it is 2 times V peak over pi. And we get VO average, and from VO average we can then plug in the equation for RL to be equal to VO average over I average, and we get RL to be around 1.98 kilo ohms. Okay, 1.98 kilo ohms. Okay, so therefore from the equation of VO average and from VP we can find RL. Okay, now the last question in this type of problems, we were given a half-wave rectifier whose input is a triangular wave. So the input waveform is a triangular wave as function of t. And since it's a half-wave rectifier and VD on is assumed to be ideal equal to 0, okay, then we expect the output to be equal to the input when the input is positive, meaning greater than VD on, and to be 0 otherwise. And this is why we see that the output takes the triangular form in the first half cycle, and then it is 0 afterwards. Okay, so this is between 0 and t. So given that VO average at the load is 7.3 volts, we are being asked to find what is the peak of the input signal for this circuit. We know that VO average is 1 over T times the area, so the average output, it's equal to 1 over T times the integral of VO of T, which is equal to 1 over T times the area under curve, which is under VO of T. Okay, now the area under VO of T is really restricted to this region between 0 and T over 2 because this is 0. So it is equal, therefore, to the base. It's equal to the base, okay, times the height over 2. يعني الarea is 1 over T integral times the base times height over 2. The base is T over 2 as we see here. It's because the triangle base is T over 2 and the height is V peak. Okay, and if we reduce this expression, we find that VO average is equal to VP over 4, and therefore knowing VO average, we can find what VP is equal to, and therefore VP comes out to be 29.2 volts. Okay, فإذا first we figure out what's the shape of the output, then we know that the average is the 1 over t times the integral of VO of t. We know how to find the integral, which is the area under the curve. And we calculate it in terms of the base and the height. And therefore, we can find VO average as function of VP. Okay, and derive VP from it. Okay, great. Now, the fourth problem that we have here is about semiconductors. We were given a semiconductor block or conducting block that has donor atoms, okay, with the donor density taking this function. Okay, so this means I have electrons. And what matters for us is that you remember and know if it is n-type, we have electrons for the sake of the transistor for you to be comfortable with it. And of course, knowing the p-n junction. So, given this donor density and given the constants in the equation, we are asked to find the diffusion current. And we were asked only to find the diffusion current, okay, at a specific point. Okay, at a specific point, if this is L and this is 0 and this is X, at X equal L over 2. Okay. And we were told that the diffusivity constant of the electron is 25 centimeters square per second, and that of the holes is 19. Therefore, and we were asked to ignore the minority carrier. So since I'm being asked about the diffusion current, and since I have donors, yani this is what I'm going to need. I'm going to need the electron diffusivity. Okay, so only diffusion current for electron because they are the majority carriers. And the equation becomes J is Q times dN by dx. And we do the differentiation, okay, of the dopant density, the derivative of the dopant density. Remember that it is going to be 2 times 1 over L times X over L times the constants, okay? So 2 times X times over L times 1 over L. And if we plug in the numbers, be careful in any exam, in any other questions, and make sure that all your units are homogeneous. In this case, make all the units in centimeters since the answer is required in ampere per centimeter squared. Okay, so make sure everything is converted to centimeters. Okay, thank you.